Hi, it's Mark Gallucci with Digital Control Incorporated, here to talk to you about interferences that you'll be dealing with while you're drilling with a DigiTrak F5 locator. So there are two kinds of interferences that you need to be aware of. There's both active and passive. An active interference is anything that creates its own magnetic field, has its own magnetic signal. Typical examples are overhead power, underground power, traffic loops, cathodic protection, tracer tone lines, electric fences, automobiles or any moving vehicle, and radios of all kinds. All of these items produce their own magnetic field. When these magnetic fields are A, just so overwhelmingly strong that they overpower our receiver, think of drilling next to a 15,000 volt power line. Or B, they're operating right or close to the frequencies that the transmitters you have are. Think of a tracer tone line. Many times those are right down in the kilohertz signal where we operate. Then we have passive interferences. A passive interference, well, they block, distort, misshapen, absorb the signal that we're trying to pick up. Typical examples would be mesh, steel pipe, rebar, chain link, guardrail, railroad track, again, motor vehicles, any body of metal essentially, also salt water and earth high and conductive material. All of these things can affect our signal. So what are the effects of these interferences? Well, let's talk about the active interference. An active interference typically will cause your signal strength to fluctuate, your depth to fluctuate much greater. Remember, signal strength and depth are one and the same. The stronger the signal strength you pick up, the shallower the depth reading. The lower the signal strength you pick up, the deeper the depth reading. So an active interference is going to make your depth typically do this. The other thing it can do, it can knock out your data signal. When you hear us use the term data, we are specifically referring to pitch, roll, temperature, and battery life. Those four components make up the data signal. An active interference can't make a 12 o'clock reading register 7 o'clock. It can't make a minus 17 pitch reading show up as plus 5. It doesn't work that way. But what it can do, it can weaken that data signal. It can block that data signal altogether so that you're no longer getting that information. The F5 receiver has got a graphical indicator, a bar, that lets you know the quality of the data signal you're getting, so you can help identify if you're in that kind of an environment. What are the effects of a passive interference? Well, a passive interference typically weakens the signal. What's a weaker signal mean? It means a deeper depth. Have you ever been drilling along and you're at 5 foot deep, you're drilling along, you put one more 10-foot rod in the ground, and you picked up a foot in depth even though you were at 0% pitch? You back it out, you're at 5 foot, drill it in again, 6 foot, you didn't pick up an extra foot in depth. You drilled beneath something that has weakened your signal, therefore giving you the illusion of being deeper than you actually are. That's a very typical example of a passive interference. Also, a passive interference can throw your locates off. You're drilling next to a chain link fence or a 42-inch steel pipe, drilling along, and it's pulling your locates over. You know, the operator says, "Hey, I told you, drill left." You know, we did drill left. We'll do it again. You know, drill another rod there. "Oh, yeah, I told you to drill left. I did." Those locates are being pulled away because of a passive interference. It's very possible. So how do you identify these areas, these problem areas? Well, to identify a active interference, it's quite simple. You walk the bore path. You walk the bore path with your DigiTrak handheld receiver turned on, but the transmitter not turned on. Let me give you a quick example. I've got a DigiTrak 5 here in my hand. I'm going to go ahead and we'll turn it on real quick. We'll turn it on real quick, and I'm going to just show you an example of a background interference. Let's do it. Boot up cycle. There we go, booting up. Okay, we're going to get to the main menu here on locate. Okay, so here we are on locate. We are indoors right now. So we can see a little bit of signal strength. That's not bad. If I was on a job site, I'd feel pretty lucky if my background noise was that low. But let's throw an interference into the picture. I've now just placed a phone near that. And notice how that signal strength number skyrocketed. That is a very clear illustration of what you're going to see on a job site. Okay? I've taken many calls from contractors who they're having a problem, and you ask them, well, did you do a background check? Well, no. Why not? Well, there's nothing here. Well, unfortunately, you guys cannot see magnetic field lines any better than I can, but the DigiTrak receiver, that's its job. It will be able to identify if you're walking into an area of high background noise. The DigiTrak F5's got 5 frequencies. You could walk the bore path in listening to 12 kilohertz signal. Come back the other way, listen to the 19. You know, go again, listen to the 18.5 or the 1.3. The F5 is a very powerful tool with regard to identifying the problems. So that's what we mean by walking the bore path. If you do get to an area where you see high noise, you need to flag that area so that later on in the day, you're prepared. You can deal with it. What do we mean by prepared? Well, if you're worried about losing the data, have your drill rig operator start marking your drill rods. Mark the 12 o'clock position. Hey, we might have 3, 4, 5 rods of an area where we're not getting the data information. Not a problem. You can mark your drill rods for 5 rods and not lose any production whatsoever. What's considered high background noise? Well, that really is a function of how deep you're drilling and a function of the transmitter you're going underground with. But as a general rule of thumb, we like to tell guys you need to have the signal strength from your transmitter at target depth. Otherwise said, if I know I'm going to 10 foot, I know what my signal strength is. I want that signal strength to be 200 counts, maybe even 250 counts higher than my background noise. Then we feel comfortable. Okay, so that means you have to know what your signal strength at target depth is. That's a very easy number to get as well. In the morning, when you checked your calibration, you went out to 10 foot and you made sure it still says 10 foot, you're going to a 12-foot drill today. Let's move that out a couple more feet and let's record that. Now you know what your signal strength is expected to be at 12 foot of depth. Now you have that number. So when you walk your bore path, you can reference the background noise that you pick up as you're doing a background check with your target depth signal strength. And you can go, oh yeah, that's right. I remember I need to have at least 200 counts of separation. And that's it. If you have 200 counts of separation, you feel good. Chances are you're going to have a good day drilling. Also, again, you can walk the bore path and all the frequencies to identify which frequency works best or which frequency is least likely to be affected by these background interferences. We'd much rather have you do that than wait till you get 400 feet out on a 600-foot bore and you realize that now we're having a problem, and you sit there and scratch your head and maybe you think your equipment is broken, or maybe you go, oh, why didn't I go underground with that 19 kilohertz signal? We could walk right through this right now. Or, hey, guys, we need to change frequency, our dual frequency. Let's use that dual frequency. The whole idea of walking the bore path and identifying these things is really to save you time. It's to save you money. At the end of the day, at the end of the week, at the end of the month, at the end of the year, if you take these few precautions that really cost you very little in time, you're going to be money ahead at the end of the year, and you're going to be much better locators, much better drill crews because of it. So how do you deal with these interferences? Well, let's give you an example that I often use. We're driving down the road in our pickup truck and we're listening to music, and we drive underneath a high tension power line. What happens to your music? It gets fuzzy, doesn't it? It gets all staticky. Once you drive away from that power line, you get good clean music again, right? How about if you're driving down the road and you drive onto a big steel bridge? While you're on that bridge, once again, you get static music. The steel bridge is a passive interference. It's blocking the signal you're trying to get. The high tension power line, that's an active interference. It is definitely creating a big magnetic field that's affecting you. But in either one of those cases that you're driving down the road listening to music, as soon as you got away from that power line or as soon as you got out from beneath that steel bridge, you once again had good, clean music. Well, the moral of that story is separation. Separation is the key to getting in, around, or through these problem areas. Now, a DigiTrak, all DigiTraks have techniques, multiple techniques designed to help you get the handheld receiver away from the source of the problem. The easiest one is merely hold the DigiTrak higher off the ground. The F5 has got a HAG setting, that stands for height above ground. And this video is not going to go into the HAG setting, but very quickly, all that does is allows you to tell the DigiTrak how high off the ground you're holding it so that you can hold it away from the problem. Another technique is remote steering or target steering. You know, in remote steering, we physically put the receiver on the ground and we watch the locate point ball on the screen progress up right up the vertical crosshair. As that progresses, we know where we are steering in reference to that box. I use remote steering when I have to when I have to cross something. I'm crossing a power line, I'm crossing a steel line. By getting that receiver out in front, away from the problem, we're getting better locates. There's also target steering, which is remote steering done one better, because with target steering, you literally load in your target depth. You tell it how deep you want to be during that section of the bore. So again, we do that when we have to cross a problem. If you have to parallel something that's causing you heartache, we do what we call off-track guidance. You do not have to be directly on a bore path to use a DigiTrak receiver, and that goes for the Mark series, the Eclipse, the F5, the F2, all of them. You have the ability to control a drill string some distance off to the side. Now again, this video is not going to discuss the HAG, height off the ground, the target steering, or the off-track guidance. Look for other videos that go into more detail regarding those topics. But just be aware, there are techniques available to help you get through these problem areas. You know, other possible solutions. Well, quite obvious, switch a different frequency. You know, if you've got a dual frequency, you're really money ahead, because now you've got two frequencies and one transmitter that you can very quickly change frequencies on the fly. You can go to a stronger transmitter. We make 19-inch long frequencies that can be used with the F5 receiver, both 19 and 12 kilohertz signals. Now mind you, they're 19-inch long, that's 4 inches longer than a standard transmitter, so you're going to need a different housing to accept that, but again, the option is there. You also could go underground with a cable transmitter. Now the beauty of the cable transmitter, not only is it the most powerful transmitter we make, but the data, the pitch and roll, it's all being fed back up a wire. It cannot be affected by these active interferences. All possible solutions. You know, another couple other things you can do is I've actually drilled in late at night, because late at night, what was once a heavy background noise interference area is no longer. You know, when the business day shuts down, closes down, the substations that are supplying that specific area, well, they're not clipping along at 80-90% anymore. You know, they're barely on at all. So what used to be a problem is no longer a problem. Mark your drill rods. I think I already said that. If you think you're going to a bad area where you might not have your data, just have your drill rig operator start marking his 12 o'clock position. The beauty or the nice thing about these interferences, they're typically short-lived. So you really only need to figure out how to combat these things for a few rods. And it's not difficult if you can identify them. If you know about them, you can deal with them very effectively. There are techniques involved, there are other products involved. At the end of the day, at the end of the week, at the end of the month, if you're aware of these things and you deal with them, you're much more time ahead, you're money ahead. So, hope you've enjoyed this presentation regarding interferences. Look for other videos that'll give you more information on how to better operate and use a DigiTrak F5 receiver.